I'm going to describe my solar hot water heater using these solar panels. These are salvaged panels from a commercial system. These are rejects. They got damaged. This one you can see is bent. Some of them are scratched. They still put out some power though. And they're rated. I'll get the nameplate rating here for you. See if that works. They're 380 watt panels. Anyway, I have my homemade rack here. Made it out of old some salvaged hoop house frame, and then I used iron ridge rails on it. So that part is basic commercial. These are some of the same kind of panels that got cracked. They're not in the system now. So right now I have 6 of these uncracked panels in series. So it's like 240 volt open circuit. And these cracked ones I don't have hooked up right now. Okay, this is the hot water heating. It's drained out because it's frozen. I mean, it's freezing out. This is a conventional hot water electric heater. And they have 2 heating elements. This is the top one, which is open and taken out. This is the heating element, or type of one. They screw in there. Anyway, is the existing heat control for the that it comes with from the factory. Now on the bottom here I have the same kind of heating element, but it's hooked directly up to this. The wires go directly to these, because this is coming direct DC from the solar panels that I just showed. And I'll explain how all these pipes work, but this small heater, this is a little 2-gallon heater, has the same kind of heating element in it, but this one is hooked up to AC through an inverter. And these are the controls. Here's how I handle the frozen hot water heating. Since this is an unheated shed, I have to drain it. But I have this pump. This is a small washing machine pump, like out of a Maytag washing machine. It just runs on AC. And I have it stuffed in this plastic here just to give it a little protection. And I have quick couples on here, so I had to make an adapter. I made this adapter to go to hose fitting, because everything I do is usually temporary or quick. So that just plugs in there, and then the outlet is here. This is the inlet. The water comes in the pump. The pump pumps it out, and then it's going to go out up this pipe, which I have another quick coupler on. It just snaps in. So the pump I brought inside to keep it warm, keep it from freezing, because it gets a little water inside and it'll freeze it up. And I have these valves here, so now water will come up, it'll go up this pipe, it'll go all the way up to the top of this small 2-gallon heater. It goes in here, fills up this small tank, and then the pump pumps it back out. It comes back down out of this one. This is the outlet. There. Okay, that comes out of this pipe. Comes down here to this hose. And this hose goes into here. So the water's always circulating. It'll be going from the bottom of this water heater up to the top of this water heater, and then back down into this water heater. So otherwise, if you tried to heat the water this way, what happens is the hot water goes up and the cold water will sit at the bottom and it'll be uneven. So I want it to circulate and be even heated, same temperature from the bottom to the top. Plus, I have to get it from this top water heater to the bottom one, so I need the circulating pump. It does two things at once. And so the reason I have this little one is because I want to be able to use the AC on this one and use the DC on this heating coil. Remember, they're one of these, except the one in here is probably a little bit longer, but that's what's in these. These are resistance heaters. They're just a big resistor, like a toaster oven wire. If you looked at one of those, you put electricity in them and they get hot. And if you were to heat this up without being in the water, it would burn out. But in the water, it just transfers its heat to the water. And then, so I don't have any water in here yet. I'm going to fill it up. It comes through this valve to the pump. And this clear hose here is like a sight glass, because I want to be able to fill this water heater up, not all the way. I just want to put in maybe, 5 gallons. It holds like 35. I might want to just put in 7 or 8 gallons or 10 gallons. So the only way to know how much water is in it to look is this fills up the water level. You can see the water level rise on this pipe, clear pipe, which you call sight glass. So I'm going to fill it up to about here today, and that's probably about 1/3 of the capacity of this water tank. The reason I don't fill it up all the way is because our days are short now in the winter, and it's partially cloudy, and I don't know if I'd have enough energy to heat up all the water I want to, or the whole thing. And so I have 2 solar systems. I have that direct one I just showed. There's no batteries involved in that. It just goes direct to this bottom heating coil. And then the other one comes from energy that's stored in these batteries, which comes from a different solar system. And it comes from the inverter here. Outback 3500 watt inverter, and this is the Midnite solar controller. There's another controller. They're both of these are on the same battery system. So there's a lot of power here that'll go into the AC. So once I have it set up with the controls on here, on this has a auxiliary contact in it. It has some intelligent, it's like a microcontroller built into it. So what it'll do is when these batteries are full, it'll fill up these batteries first. And then when these batteries are full, it will tell the auxiliary contact in here, you can program to turn something else on. And the thing it's turning on is this. It's going to turn on. I'll turn this back on. It's going to turn on this heating element. Okay, these relays, this one here is the AC relay which goes to this top water heater heating coil. You might be able to see it's flickering, the LED is flickering. That's because it's doing what they call PWM, pulse width modulation, and it's turning the relay on and off real fast so that it can just put enough power into the heating element as it needs to heat the water, but it'll still keep the batteries full. And this one controls the pump, and these are temperature sensors, thermostats, so the water temperature can turn these on and off for the pump or the solid state relay. And the DC is this one here. Right now it's off, but it's the open circuit voltage is 281 volts right now, and instead of a relay it goes to this, which is called a IGBT block. It's bigger transistor, it's like a big transistor to control. It can handle high voltage and high current. Mainly the high voltage I need from the direct DC, which is, this is what this is. This is the one just for the direct DC from the solar panels with no batteries or anything. And I had it on this in the beginning, a regular relay that was rated up to, I can't read that right now, 100 amps, 220 volts DC. But I burned it out because, as you can see, this is 289 volts. So it gets higher voltage as the temperature gets colder outside. So it worked for a while, and I put another panel on there too, which brought the voltage up. So I have 6 panels in series. Anyway, so this here is on a big heat sink because it's not 100% efficient. So when the power is going through this IGBT, some power it takes some power to just run it. It loses some power, which is in the form of heat. So it'll heat up this big piece of aluminum heat sink. Has to take away the extra heat. When I first put it in, I had it on a smaller heat sink, which got super hot. I don't know where I put that little heat sink, so I put this bigger one on. It's been okay, because I calculated out it loses about 15 watts worth of heating into this heat sink, which can get pretty warm in a small space. So that's why you need a bit of aluminum to dissipate the heat. So I'm going to fill the water heater up and then turn these on and get it heating. See that rare sunshine we're having? Amazing. It's been cloudy out here for 2 weeks. And I'm filling up the water now. It just filled up the pump. I fill it through the top of this. Just with the garden hose, I'm filling up the water into that top hole. I could do it differently, but this is the way I do it right now. So right now I have the valve closed here for the sight glass because it's cold and this is real small and it would freeze. So I'll wait until the water gets up a little high before I open it, and then the water will rise up and I'll be able to see how much is in there. Okay, I got the pump on. You can see there's a little bit of air getting sucked in there. So you bump this on and off a couple times so that you get the air out of the impeller in here. So it's going to go up and fill up the top water tank now. I'm running low on battery, so I'm going to have to do this quick. Okay, I've had this filling a little while. Let's see, I'm going to open up this valve and see how high the water comes on the sight glass. There it goes. And it's this high. I don't know if you can see it. Here's the water level right here. So there's this much water in the tank. I gotta have it at least above this heating coil here, so that's about all I'm gonna put in there for right now. And then later in the day, if the sun stays out, I can put more in. So I take this out, put the one from the little water heater in to circulate, and that's it. Now I turn these on. I had these off because I didn't have water and didn't want to burn out the heating coils. So you can see the voltage dropped way down now, and now that there's a load on the coil. It was 280 volts, but now I'm only getting 107 watts out of it. Solar panels, until the sun comes back out, it'll go up close to 1,000 watts. That's if the sun comes out. So you can see 4 amps. It's going up. Sun's coming out a little bit. There it's up to 483. So this is just a monitor. The DC comes in these wires. It goes through this breaker, this DC rated breaker. Then it goes through this, which is like a switch, the IGBT, and it goes on the wire to the heating coil, the bottom one. And this is the water temperature in Celsius. This side controls this AC, and this side controls this DC heating. And they're both set at the same temperature. So when the water gets hot enough, it turns these off. The low voltage goes into the bottom of these, which controls the high voltage at the top of them. Same with this. The low voltage from the thermostat will turn the high voltage here on. And then this one is the water temperature in Fahrenheit, and this one is controlling the pump. It turns this relay on here that turns the pump on and off if I had it hooked up. But in the cold weather, sometimes now what I need to do is just leave the pump on 100% all the time so it doesn't freeze. So we'll let it sit and cook for a while and hopefully heat up this water. Okay, the sun is out a little better. So I'm getting 400 watts into the heating coil. And then this side, that's the PWM, is on. You can hear it. You can see it strobing. It's on probably about 75-80%. So it's almost giving all the power it can to the heating coil. And here's the sun I'm working with. Guess you can't see with the camera. So it's not perfect sun, but it's better than nothing. It's what we get here in Wisconsin in the winter sometimes, especially this winter. We're getting good sun now. Let's go see how much energy is going into the water heater. Okay, good sun, 1200 amps, 9.7, 1200 watts, 9.7 amps, which is pretty close to the full rating of those solar panels. And then I turned the pump off so you can see on this that the little water heater on this side, which is small and it's getting a lot of energy, the temperature has risen quite a bit more than the big tank below it. So I'm going to turn the pump on. Okay, I just turned the circulating pump on, so we should see the temperature go down on this side and start to go up on this side. It might take a while to go up on the other side, but you can definitely see it going down on the small tank as it pumps the colder water into it. 1,000 watts, close to 1,000 watts in there, so that's nice. And this IGBT, it's a little bit, it's not warm, but it's not cold, so you know it's taking some heat in there. And then the batteries are full, so this is on almost 100%. Okay, this is some info on the AC side of the solar system. This is the controller, one of the controllers, the main controller. The other one follows this one. And you can see on here that it says that I have 7.7 amps going into the batteries now. And the batteries are 100% full. And they're in float because they're 100% full. And it's putting out 835 watts. Relay number 1 is on, which I have available for the pump, to turn the pump on and off. I'll go to the second solar system. You can see that's putting out 1,000 watts, 800. It's going to fluctuate. And I'm going to turn, it has relay number 2 on, that does the PWM. I'm going to turn that off just to show that this will go way down. Go to advanced on configuration. This is relay number 2 that does the pulse width modulation. So I'm going to turn it off. There. See, that dropped. Turn the relay off. It dropped because there's no power going into that upper small tank heating coil now. And you'll see on the other one, the other controller 2, there's no power. I'm going to turn this back on. Go back to controller number 2, the hoop PV. Configuration, advanced, auxiliary 2. I'm going to turn this back on, which you go to auto. If you turn it on, it'll be on all the time. We just want it to work automatically. This makes the changes permanent. And then, there it goes. See, the power went back on and it's going back into the heating coil. So this one's 1,000 watts. And this one, if I go back to the other controller, it's 800 watts. So that one probably has about, I don't know, it probably has like a 1,200 watt or 1,200 watt heating coil in it, I'm guessing, heating element. So most of that power is going into the water heater now. The top unit, the bottom one is getting the DC, which I showed earlier. I don't have it on the computer here. I have this nice little Arduino remote temperature sensor, so I can monitor all the temperatures and various things. There's the water heater. It's up to 58 degrees now. And then these are my refrigerators. They just cycle through temperatures on the refrigerators and freezer. And here's the water heater, 58 degrees. So I can kind of monitor the water temperature from inside here. We're using one wire temperature sensors. So the sun's been out pretty good. It's 1:30. Sun's still pretty high. We got good sun on the solar panels. Let's go see how hot the water is. Okay. 84 volts. 517 or 600 watts, about 6 amps. So the sun isn't directly over the panels anymore, so it's not at their peak. And the water temperature is almost 100 degrees. It's 98.9 Fahrenheit or 37 Celsius. And the this is the AC side. It's still giving it all it's got into the heater. And let's see if this is warm. No, not warm at all. The IGBT. So what happens is when this gets up to temperature, I'm going to pull the fuse. So when this, the control from the Classic comes, is just like 12 volts, and it comes through the contact on this thermostat. There's a switch, goes on and off. So when it gets to temperature, the switch will open up. It's closed now, so it lets the current go through, lets the power go through, and it goes to the bottom of this IGBT coil. So if either the auxiliary contact on the Classic opens up, or if this opens up, it will shut the power off. And I'm going to simulate that by just pulling the fuse for this circuit. If I can get it out one-handed here. Come on. It's in there tight. Okay, there, I pulled it out. See? It just went to 0. And then the voltage went up, so it's showing the full 282 volts. Open circuit voltage. This is for the solar PV direct. Now I'm going to put the fuse back in, which is simulating the switch going back closed. There, see it drop down to 80. So that's how it works. Anyway, I have these set. I wanted to get this water up a bit hotter. See, it's already got to 100 degrees since I came out here. I'll get it up to 105 or 110 degrees or warmer, because I got to make up for the cold weather out here. So we're almost gonna do it. I should explain a little bit. Like in the summer, when we have lots of daylight and the water, you can leave the water in there. The water's warmer. I don't have to drain it. I will just use this to heat. But in the winter, with these short days, and you never know when it's going to cloud up, I want to put as much energy in as possible in a shorter time. And so I can only put in, like, you know, you see I'm only getting 6,000 watts on this. But when I add this one in, the coil in this little water heater, then I'm doubling my heating capacity. So if I could have 2 heating coils down here, like one here, and if there was a place to put another one here, that would be ideal. But in these regular water heaters, there's one here and then one way up here, and I don't want to heat that much water. So otherwise I would just have 2 coils here. I could either have 2 12 volt or 2 DC ones, or split them up, 110. But we gotta do what we got. Work with what we got here. And that's what I do.